Find the oxidation number of the following. Now we're given some couples of compounds here to look for the oxidation number. Now let's look at the first one here. You have to know that finding the oxidation number can be basically in two ways. If we see some compounds are neutrally charged, meanwhile some other compounds they have a charge. Now know that the oxidation number of neutrally charged and compound is always 0. Meanwhile, the oxidation number of a charge of all ionic compound is equal to the charge of that particular compound. Now let's apply that here. Like for this, hydrogen to SO4. Now the oxidation number of hydrogen is 2, is 1, but there are 2 atoms of hydrogen multiplied by 2 plus sulfur. You don't know sulfur. That is plus oxygen. That is minus 2 times 4 will be equal to 0. It's a neutral compound. That means we sum up the oxidation number, and it will give us what? 0. Therefore, opening this, that will be 2 plus sulfur plus minus 2 times 4, that is minus 8 to be equal to 0. So that's going to give us S sulfur plus 2 minus 8 will be equal to 0. And 2 minus 8 will give us minus 6 equals to 0. Sulfur will be equals to plus 6. That is, the compound here now is pronounced hydrogen tetraozo sulfate 6. That is hydrogen tetraozo sulfate 6. Hydrogen tetraosulfate 6. Now that is the name of the compound. Now recall I say that this is a neutral compound. That means the sum of the oxidation number of all the elements present here should be equal to 0. That means as we have found the value of sulfur, if we add up sulfur, substitute the value of sulfur into the compound, it should give you 0. For instance, now sulfur is 6. So this is 6 plus 2, that is 8, and 8 minus 8 to be equal to 0. That is applicable on all the neutral compound, that is compound that don't have charges. So this is for sulfuric acid. So let's look at this number 2. Number 2 say calcium into nitrate 2. Now this is calcium nitrate. And for you to find the oxidation number of this, the process is still the same as we did here. So this is going to be oxidation number of calcium is 2, that is plus 2. So you may be wondering, what is the oxidation number? How will you look at an element and then find its oxidation number without thinking twice? There is a very simple process to that. You can go to my videos when I did videos on finding oxidation number of every element. It's just for you to use the above method. Alright, so you go to my other video. So nitrogen here, the whole of the element present in this bracket is multiplied by 2 outside. So that is 2 times N. We have 2 nitrogen plus 2 times D, that is oxygen 6. That is 2 times 6 here. 2 times 3 here will give us 6. Then you now open 2 plus 2 nitrogen. Recall it's a neutral compound, so it will be equal to 0. And then plus oxygen, the oxidation number is minus 2, but that's 6 here. 6 will be equal to 0. So that is 2 plus 2 nitrogen minus 6 times this, that is minus 12, will be equal to 0. So 2 nitrogen plus 2 minus 12 will be equal to 0. And if we minus this, what are you going to have? 2 nitrogen, 2 minus this, that is going to give us minus 10 will be equal to 0. So taking 10 to the other side is going to turn to positive. So we're going to have 2 nitrogen will be equals to 10 plus 10. And then you divide both sides by 2 and by 2. When 2 cancel 2, we have seen that nitrogen is equals to plus 5. That means the name of this compound will be calcium triazo nitrate 5. So that is it. The oxidation number of nitrogen in this particular compound. And if you know that if you test it by substituting the value of nitrogen in anywhere around here, and then you sum up again, you discover that the sum of the oxidation number for all the elements will be equal to 0 because it's a neutral charge, neutral compound. Now let's look at this other one, the number 3. The number 3 says nitrogen. Now this is an ionic compound because it's having charge there. Now for ionic compound, the sum of the oxidation number of an ionic compound is equal towards the charge of the compound. Here is this compound is charged -1, so we are going to have nitrogen plus oxidation number of oxygen is just -2. -2 will be equal to, there is 1, so we have 1 minus 1 there. So if this is going to just be nitrogen minus 2 will be equal to, let me write 2 very well, equals to -1. Taking 1 to that other side, nitrogen will be equal to -1 plus 2. And we're going to have the nitrogen will be equal to -1 plus 2. That is going to give us +1. All right, so the value of nitrogen here is +1. Now, let's look at what happened. So this is nitrogen +1, and then oxygen is -1 here. So you are seeing that the sum of the oxidation number, oxygen plus -2. So that if you have +1 minus 2, it will still be what? -1, which is the ionic charge on this particular compound. This is an ion, the charge on this particular compound, -1. So the sum of oxidation number of ionic compound is equal to the charge on that particular compound. That is what is there. So you sum -2 plus 1, it will give you -1. Yes. Now let's look at the last one. This last one is carbon, 3 atoms of oxygen and minus. Now note that there's a difference between -2 and 2 minus. This one is what? Ions. Meanwhile, this one is oxidation number. Oxidation number, the charge will come before the number, but in ion, the number comes before the charge. These are very important points that you will not forget. All right, so now to find the oxidation number of this particular compound, recall that this is an ionic compound. So the sum of the oxidation number of all the elements here will be equal to their charge. So that will be carbon plus -2 times 3 will be equals to the charge there is -2. Now, if you express this, you're going to have the carbon plus this is -6. -6 equals to -2. This is carbon -6 equals to -2. Taking to the other side, we have carbon will be equal to -2 plus 6, and this have shown that carbon is equal to +4. So now, if we substitute the value of carbon here, which is +4, this should give you the sum of the oxidation number should give you what? They should give you -2, which is the charge of this particular compound. And of course, this is here is -6, so -6 plus 4 is equals to -2. So that is how we add them. We sum up numbers, or we express the oxidation number of every compound. Just for the two laws, the sum of oxidation number of